Thanks for the introduction and the opportunity to present this work. As our team was doing this work, this analysis, I always envisioned some sort of presentation, but never quite knew, what the audience was or who, because it gets pretty detailed. But as it turns out, I think IT confidence is just the right forum for this. Okay. All righty, so this presentation is kind of divvied up into three parts. The first is the look at the data, the normalization, some of the things we had to do with the data cleansing. The next part is the analysis and looking at the ranges and the trends. And then lastly, about how we took these findings and used them to inform some of the Agile estimation in SEER-SEM, SEER for software. And by the way, SEER for software is our company's software estimation application. Okay, a little bit of caveat first. I'm stipulating that functional size measures are the way to go. And when I talk about velocity and productivities and things like that, it's all in the context against functional sizes. There's other presentations that I have that talk about why it's good to use functional sizes, but like I said, this is assuming that's the case here. So this analysis was done based on the 2022 release of the data set. That release brought a critical mass of projects that also included not only functional size and the normalized work effort, but also information about the number of sprints, sprint duration, and in some cases, team size. So this presented a great opportunity for us to look at that data and evaluate it at a very granular level to see if we could use it to improve the estimation. We use the data, the ISBSG data, along with other data at a kind of a macro level to get overall estimation, productivity and things like that. But we wanted to see if we could use some of this more detailed data for further drilling down. Okay, so we started with a data review. The first thing we did, and anyone who's used the data set will recognize this shot of the spreadsheet. These headers are very familiar to those who've worked with the data. We took data or the data records that had non-zero or non-blank values for the number of sprints or iterations. That's because we really wanted to look at what's happening with a project when it gets divided up into different sprints, and how can we look at kind of some of the effort at that lower, more granular level. So that was the first cut, and that left us with 1,021 records. So not obviously it's less than 10% of the whole data set, but still a good critical mass of the data. Next, we looked at some of the review of the sprint duration, and I have a little more of that on the next slide, but basically the sprint duration, which in the data set is expressed, or at least the definition is in terms of number of days. There was a little bit of work we wanted to do with some of that, some of the records that had some values that were maybe work days versus calendar days, things like that. And then looked at kind of some oddball projects. There were a number of them, 77 records that had one sprint. Well, 52 of them were 1 month duration. So, okay, they were just short little projects, so one sprint project kind of thing. However, there were 24 that said, we have one sprint and they were 12-month projects, but then their sprint durations kind of indicated otherwise. And in those cases, we used the sprint duration to kind of determine the overall duration of the project, as well as one project that had no duration. Okay, so this is what we did with the sprint duration. our objective, we wanted to get it in terms of number of weeks, in part because that's how SEER-SEM uses sprint duration, or takes sprint duration. That's kind of the unit that SEER-SEM uses. There were some records where the sprint duration in days, they were 2, 3, and 4, and it was pretty clear that those were probably weeks. I understand that that's been kind of cleaned up in newer data sets, but at the time I didn't have that. So, and then there were some where the question was, are these days work days or calendar days? If they were evenly divisible by 7, I assumed those were calendar days. Otherwise, I kind of assumed they were work days. And then there were some records that, had 10 days, as it said 7 to 14 on there. So we just had to make some assumptions. This way we had every record with the sprint duration expressed as number of weeks for sprint duration. So we haven't really done much other than a little bit of normalization and cleansing. Looked at the overall, okay, what do we have as far as a data set? And by the way, this kind of format of a table, I use quite a bit in my analyses. Basically, so for instance, the number of sprints, the maximum number of sprints was 39, the minimum was 1. This mid one shaded is the 50th percentile, or the median of the data set. And usually in big data sets, that's usually kind of what we look at, the median. In these cases, the median and the average were not all that different, but sometimes if there's a lot of outliers in a data set, they could vary quite a bit. So median number of sprints 13, functional size 819, number of months 8.8. This all looks kind of pretty reasonable. Nothing looks kind of out of whack, or in terms of what the projects look like. Okay, so the next thing we wanted to do was say, okay, what was the team size for these sprints? Now, there were the ISBSG data set does often have a stated average team size, but not all records have that. And now that we have sprint duration in terms of weeks, and the overall work effort and everything, we're able to derive and do what I call a backfired team size. And that basically, first thing we do is we determine the number of hours per sprint, which is the normalized work hours, or normalized work effort divided by the number of sprints, and then normalize that to hours per week, which we take the hours per sprint and divide it by the sprint duration weeks, and then divide that by 40 to get basically a backfired team size. And you can see the stated average team size on the right side of the table. It's pretty consistent with the backfired size. However, this gets us, about 100 more records to, about 100 more records to work with in terms of team size on there. And the other thing is it kind of gives us some reasonable ranges on, what the team sizes are in this case. And in fact, I do have the maximum team size, the 99th percentile was 10 or 11. So, most teams are, between, maybe 2 and 11 people. So that gives us kind of a good working range for team size. Okay, so next we talk about velocity and productivity. So productivity is the measure, we use that to measure, benchmarking the overall project, where we look at functions per work hour, functions, usually it's functions per hour on that. Now, a sprint productivity would be the functions points per sprint, but that's really a velocity. That's how much you can get done. And it's a subtle difference, but it's an important difference because we want to be able to compare productivities regardless of whether a project had 5 people on a team versus 3 people on a team, or they were 2-week sprints or 4-week sprints. So what we did was we have a normalized velocity, which was the number of function points per sprint week. And so that actually, we can compare the velocities a little bit, but then we took it to the next level to come up with a normalized productivity, which would be the function point, that velocity divided by the team size, or the number of people. And that gives us kind of a sort of a micro productivity value at a sprint level on there. So this, and the reason we did this is because we want to start looking at, okay, what happens when your team size gets bigger or smaller on there. So this kind of gives a view of the ranges for that, the normalized velocity and the normalized, what I call kind of productivity or function points per sprint week per person on there. So this is kind of the individual contribution to the effort in terms of productivity, and this is the overall team contribution. And note, if you go back a couple slides, if you take that normalized velocity, this column here, and divide it by the median team size, so this normalized velocity 24.77 divided by the median team size, which was 3.6, we get 6.68, which is tracks pretty closely to that sprint, the productivity on there. So this normalized is a normalized productivity independent of team size. Okay, so once we do that, I kind of look, okay, we've got some interesting metrics. Let's see what happens, for different sort of tranches of project sizes. And here I basically divided projects into under 100 functions, greater than 1,000 functions, and then a couple of tiers in between. And looking at the team size as this grows, probably pretty intuitively, the team size gets bigger as the project gets bigger. And that's something we see generally in data. However, the normalized function points, that productivity doesn't grow with the project size. It's kind of in some cases it's bigger and smaller. It's the average is about 6.6. So this productivity is relatively, it doesn't have what I call a monotonically increasing or decreasing relationship with the project size, which is also something we want to have. Like I said, it's a productivity. It's not, we don't want it to grow with the team size. We don't want it to grow with the project size. So I'm going to take a step back and say, okay, why are we worrying about this very low level sprint productivity? And the reason is we want to be able to connect sort of the high level estimates, which is oftentimes what you do, at least to start with maybe a more low level or granular estimate using in SEER for software, we have something called the Agile Planner. So you can do a high level estimate and say, okay, I've got 1,000 functions, and it's a cloud-based platform. Business intelligence is the application type. We're doing it in Agile, and so on and so forth. And it'll provide an estimated effort and schedule and a lot of other good metrics. But we want to say, okay, well, what if you need to take it down a level, down in detail, a bit. So for instance, what if I, only can have 3 people to put on this team? What if, I use multiple teams? What if I put a bigger team on the project or a smaller team on the project? What would the impact be? What if my project is schedule critical and I have to figure out how to get it done within a certain period of time? So there are instances, and they may not be that initial high-level estimate, but times where you want to say, okay, I need to take my estimate, but now I need to drill down and factor in these maybe very specific constraints that you have, or look at kind of strategies for how you want to go about managing the project in terms of the types of teams you put on them. Okay, so this chart kind of gets into the kind of key what we wanted to get to, and that is we want to look at the sensitivity of this productivity, this sprint level productivity, function points per sprint week per person, so very normalized value, as it changes with team size. And there's clearly a decay here as that productivity gets lower, it decays, it becomes less productive, I should say, as the team size grows. Important to note that this sort of sensitivity, this relationship, is really pretty much good between 2 and 10 people, or maybe 1 in 10 people. You can't really extrapolate it and say, if you have projects of 20, 30, 40 team sizes that big, which first of all, we didn't see the Agile team sizes get that big, but we want to make sure that this is within a good boundary there. So this gives us a basis of adjusting the individual productivity based on the team size. And once we know how to change that productivity, the productivity and the velocity are tightly related in that you can basically take the productivity, multiply it by the team size to get the velocity on there. So we can see how the productivity changes, thus we can see how the velocity might change with a change in team size on there. So this is kind of the flow chart, if you will, of how we go about in SEER for software in a very general way, on how we go from a high-level estimate to an AP stands for Agile Planner estimate on there. So the first thing you do is we have an estimate in SEER-SEM. Again, it might be a cloud-based system, business intelligence application. Maybe you're using full Agile, maybe you're using a hybrid Agile. Usually you would specify it as kind of an Agile methodology on there. So we have a baseline estimate, effort and schedule. In SEER for software too, there's a notion of a minimum time solution, which is usually the default. So we kind of optimize on that. So based on that, we come up with basically an optimized Agile team size. And that is basically the average staff based on the minimum time, effort and schedule. However, there are a little bit about some boundaries that we put on it. We don't want it to get, ridiculously small. It's got to have a minimum of 1 person on the team. And then we also do a check for what we call multiple teams. When the optimal team size exceeds about 10, it's a little bit of a rough boundary. Multiple teams are suggested, and it gives you the option to decompose the backlog maybe into multiple teams on there, so that you can, so you're not really exceeding the typical team size that we would see. So the first few steps are basically setting up, okay, we have an estimate, we've got a target team size. I didn't state it here, but the user will also put in what the sprint duration is in terms of number of weeks. And then we compute what we call an anchor velocity. The anchor velocity is computed based on this optimal team size. And that then in turn will determine quote unquote a theoretical optimal number of sprints, which is that schedule divided by the sprint duration. And then the anchor velocity is the size divided by that optimal number of sprints. So if you didn't give it a team size and you said, let me, give me the optimal one, this is what it would be, and we would have what that velocity is. Now, if you say, and let's say in an example, it was based on, a team size of 3, but you put on a team size of 5 on there, then we would have to adjust the velocity for the team size. And what we do is we take that anchor velocity, we take kind of that relationship that you saw on the previous slide. We've got some adjustments to it, but basically we have kind of a decay function so that as the team size gets bigger than the optimal team size, or I guess it gets bigger if it was on the if the team size was smaller than the optimal team size on there. So we adjust at this low level the productivity, and then that in turn determines a new velocity for the new team size. So very important. We don't assume that all the velocity. The velocity needs to change with team size, obviously, but it's not just a pure linear adjustment for the team size. We have some notion that bigger teams are slightly less productive than smaller teams. So we have that optimal adjusted velocity, and from there we can compute the new number of sprints based on that adjusted velocity. The new number of sprints with the team size provides an adjusted estimate. So again, kind of very high level flow, but gives you an idea of what's going on, excuse me, a little bit under the hood. Okay, so this is kind of just my wrap up here to talk about, how this the ISBSG data set was really important and instrumental in helping us get to that level. Not really discussed in this presentation. The data set, we certainly use that to determine general productivities for projects in general, but also for Agile projects in particular, and for the Agile project knowledge bases, even if you don't go down and use the detailed Agile planner. The SEER for software is benchmarked to a lot of the Agile data in the ISBSG data set. So that even without going into the detail, you get a good estimate based on that data. It helps with helped us with basically understanding general Agile metrics in terms of team sizes, in terms of velocities, typical boundaries that we have on it. So we have a really, like I said, a much better understanding of what's happening in terms of what you might see on an Agile project in terms of number of teams, number of in productivities. And then lastly, it helps us into what I would call that kind of micro adjustments on the estimate for team sizes. And this kind of just shows, a detailed Agile estimate where it shows the overall duration for the backlog, the velocity. And if you have, this is an example of a team size of 3 versus 2, we'll have fewer hours, but take a little bit longer and have some more additional sprints. But it's not always just a linear, okay, it's 3 people instead of 5, and it's the same, assumed same productivity on there. And that's my presentation. So I think I hit within the time zone. I guess we take some questions now.